Hello and welcome to this NCFE provider session, Cracking the Code, Problem Solving Strategies for Functional Skills Maths. My name is Charmaine Phelps and I'm a Provider Development Officer here at NCFE, supporting our providers with the planning, delivery and preparation for assessments of their functional skills qualifications. The objective of this session is to explore strategies to help learners decode multi-step problems and select the most effective methods to solve them. We'll start with an overview of problem-solving skills, then we'll look at how you can develop problem-solving skills in your delivery, then we'll look at some decoding strategies and end with a short summary. Now, I'm sure you're aware that problem-solving skills are assessed at 75% of the assessments at all levels. It can be useful to know what's expected at each level when it comes to solving mathematical problems and decision making. So we'll take a look at that now. At entry level, so at all entry levels, learners are expected to be able to use the knowledge and skills listed in the subject content statement tables to recognise a simple problem and obtain a solution. A simple problem is one which requires working through one step or process. At entry level, it's expected learners will be able to address individual problems, each of which draw upon knowledge and/or skills from one mathematical content area only. So, for example, it might just be number, or shape, space and measure, or handling information. At entry level 1, learners need to be able to use methods given to produce, check and present results that make sense and give a simple explanation for results. While at entry 2, they need to be able to use the methods given to produce, check and present results that make sense and present appropriate explanations using numbers, measures, simple diagrams, simple charts and symbols appropriate to entry level 2. At entry level 3, they also need to use methods given to produce, check and present results that make sense to an appropriate level of accuracy. So not just making sense, it needs to be to an appropriate level of accuracy. And when it comes to presenting results, these need to be with an appropriate and reasoned explanation using numbers, measures, simple diagrams, charts and symbols appropriate to entry level 3. So there's a bit of a difference, in the actual solving mathematical problems and decision making expectations across the entry levels. Now at level 1 and level 2, learners at level 1 are expected to be able to use the knowledge and skills listed in the subject content statements to recognise and obtain a solution or solutions to a straightforward problem. A straightforward problem is one that requires learners to work through one step or process to work through more than one connected step or process. At level 2, learners are expected to be able to obtain a solution or solutions to a complex problem. And a complex problem is one which requires a multi-step process, typically requiring planning and working through at least 2 connected steps or processes. At level 1, it's expected that the learner will be able to address individual problems, some of which draw upon a combination of any 2 of the mathematical content areas. So that's number, shape, space and measure or handling data. While at level 2, it's a combination of all 3 mathematical areas, and obviously be able to make connections between those content areas too. At level 2, it is expected, and at level 1, all the information here applies to both. So learners need to be able to read, understand and use mathematical information and mathematical terms required at the level, address individual problems as described above, use knowledge and understanding to a required level of accuracy, identify suitable operations and calculations to generate results, analyse and interpret answers in the context of the original problem, and check the sense and reasonableness of answers. And then when it comes to presenting results, at level 1, learners need to be able to present results with appropriate explanation and interpretation, demonstrating simple reasoning to support the process and show consistency with the evidence presented, whilst at level 2, learners need to be able to present and explain results clearly and accurately, demonstrating reasoning to support the process and show consistency with the evidence presented. So hopefully that helps you to see the how the problem solving skills change through the levels. My last CPD session looked at strategies to teach the subject content and build retrieval practice into your lessons. In this session, we're going to look at the types of activities you can use to develop your learners' problem-solving skills. In the live session, we used a Padlet in order for the activities to be a bit more interactive. You can access the Padlet now. You can no longer write on the Padlet, but you can read what was done in the session, and also you can access resources to download that we'll be using later in the session. So you can access it just by scanning the QR code. So one of the first things we did in the live session was we asked this question: how do you develop your learners' problem-solving skills? And on the Padlet, our attendees popped their responses. So I'll just read a few of them. We've got bar models, which actually we're going to cover later. Rucksack, which again we're going to cover later. What else that's different? Draw and simplify problems into small steps, get them used to visualizing it. Actually, we will be looking at visual strategies. For ESOL learners, we ensure they understand the question first by breaking it down into parts. They've mentioned goal-free problems as well, which we're going to be looking at. Systematic step-by-step approach, looking at worked examples with errors, ask them to spot what went wrong, step-by-step discussing different methods, make a story of it and try to visualize steps. That's a good strategy. Use rucksack and bar models too. Everyone sees problems differently, so lots of suggestions, and you might think to yourself as well, what do you currently do? And if you notice, actually, when it comes to developing problem-solving skills, I mean, yes, I suppose we have got breaking it down, which I suppose would probably imply that they're looking at assessment questions, but a lot of the examples that are given here are not necessarily just do practice papers. You know, that's not the only way of developing your learners' problem-solving skills. One way is to look at practical activities and projects. Your learners exist in the real world, and they will likely have other vocational studies that will also involve maths. When they need to use their math skills in practical tasks and work projects, they may not always be presented with a list of calculations to complete. They will need to determine for themselves what skills they need to use. So the more you can link in with your learners' lives, their studies, their work to identify projects or practical activities that they need to complete that involve maths, will not only help them to see the relevance of the maths that you're teaching them, but it will also give them practice in using logical thinking to solve real world problems. And maybe you can think for yourself any practical activities or projects that either you've used previously or that you could use to support your learners' maths problem solving skills. Now, here's another strategy that you can try is multiple possibility questions. I got this idea from this particular question from, I was on Facebook, I was in a functional skills group, and a learner posed a question similar to this. And ultimately, the learner who posed this question, they just wanted the answer. And I thought, oh, crumbs, that's such a missed opportunity. So here we've got the question, using the digits 5, 4, 3, 2, 1. Just once each to fill in the purple boxes below. What is the closest you can get to an answer of 300? And this kind of activity is great for getting your learners to think, to try things. I mean, yes, it's great if you can come up with an answer that is the closest to 300, but that's not necessarily the point of doing a question like this. So for example, we can just have a try. Let's just put some numbers in, see what we get. So we've put in 254 plus 31. What do we get? 285. Okay, can we get any closer to 300 if we rearrange the digits and add them together? Let's have a little look. Yes, we can. We've got 294 here. That is the closest that you can get. There is no closer that you can get. However, when we asked this in the live session, we actually got some other answers. And that's because there's actually more than one way of reaching 294. We can do it by, as I've shown here, 251 plus 43. But how many other solutions can we find? And again, we could do trial and error to see how many other solutions we could find, or we could use logic. We can try 253 plus 41, gives us the same answer. 241 plus 53 gives us the same answer. And 243 plus 51 gives us the same answer. So there's 4 possible answers. And again, if you're doing an activity like this with your learners, it's a nice sort of way of let's try and solve the problem. It's not necessarily about reaching that 294. It's about the process of how do we go about solving this problem, the logic, and then looking at any patterns. Is there a reason why there's 4 possible options? So lots of different things that you can bring out of just a fairly straightforward question like this. And bear in mind as well, this is not a functional skills assessment style question. However, it's a nice question to prepare your learners and give them the opportunity of solving problems, not just thinking with maths there is just one answer and there's only one possible right answer and that's all we're looking for. It's opening up to a bit more creative thinking. So let's have a little look at another multiple possibility question. There are 5 numbers in a data set. The mean of the numbers is 7. The range of the numbers is 5. What 5 numbers could be in the data set? Try this for yourself. We did this in the live session and our attendees came up with various different possible correct answers for this particular multiple possibility question. And again, you can extend it further. Is there how many possible answers can there be? How does that vary if we changed what we're looking at, the number of numbers, what the mean of the numbers is, the range of the numbers. Exploring the relationships can be quite useful. So again, multiple possibility questions are great for just expanding your learners' minds, give them some creative options and realizing that there's not always just the one way of going about something. Here's another activity. What's in the box? I've numbered what's in the box, 1, 2, 3, 4. I just did that purely to make it easier for the attendees writing in the chat to tell me which box they meant. But in this first column, I have 2 lines of symmetry, so it's a shape that has to have 2 lines of symmetry. But in box 1, it has to be a shape with no right angles. So no right angles, but 2 lines of symmetry. In box 2, it needs to have more than 2 lines of symmetry and no right angles. And then in box 3, I have 2 lines of symmetry and right angles. And box 4, I have more than 2 lines of symmetry and right angles. So try this for yourself. Is there only one possible solution, or are there more? So these are some shapes that I came up with. A diamond, yes, it has 2 lines of symmetry and there's no right angles. The circle, more than 2 lines of symmetry, no right angles. Rectangle has right angles and 2 lines of symmetry, and a square has more than 2 lines of symmetry and right angles. And in the live session, I think the only box that everybody had the same was the rectangle. Everybody had rectangles in that box, but the other boxes there were a range of different answers. And again, it just, it just gets your learners thinking. And you might want to think for yourself, are there any other topics or criteria that this particular type of activity would work for? And perhaps as well, how could you scaffold an activity like this for your learners? So I suppose that the most straightforward way of scaffolding it would be to give the shapes to your learners and then they put them in the right box. So lots of different ways of using this sort of what's in the box activity. SSDD problems, you may have heard me talk about these before. I really like them. They're the brainchild of Craig Barton. He has set up a free website called SSDD Problems, which I've linked here. And as with any third-party external links, they are not necessarily NCFE endorsed. However, they, this particular one or any of the ones that we share, they contain resources that we've found helpful. So the purpose of an SSDD problem, it stands for same surface, different depth. And all of these questions, they're all set out similarly to this slide. They begin with the same surface or context. So in the center, we've got our surface. A square tile has this design. Okay, that is our surface, that's our context. But then there are 4 different questions placed around that context that are all looking at a different maths topic area. And doing an activity like this, it gives learners practice in identifying which strategies they need to use. So for example, up here we've got what is the perimeter of the tile, and then moving across, what's the combined area of the green parts of the tile. So we're within the same sort of topic area, really. We're looking at perimeter and area, but for the second question, what's the combined area of the green parts of the tile, slightly more complicated than just looking at the perimeter of the full tile. Another question down here, the tiles are used to cover an area that is 2 meters high and 3.04 meters wide. How many green triangles will be on the tiled wall? So there's a lot of steps to try to solve that problem. And then down on the bottom right, what is the ratio of the black parts of the tile to the green and the purple parts? So we're bringing in another strand of maths here to look at the ratio as well as the area. So the great thing about these type of questions is typically, let's face it, what we will do as teachers is we will cover a topic, and at the end of that topic we set some assessment style questions, and our learners will probably do quite well at those assessment style questions, those problem solving type questions. Why? Because they already know what strategy to use, what math strategy to use. How do they know? Because it's what we just covered in the lesson. So we teach a strategy and then we give some problems that use that strategy. So our learners are not having to engage their brain and think for themselves, what strategy do I need to use? Whereas these SSDD problems can help break learners out of autopilot. They need to think about what strategy to use in order to be able to solve the problem, rather than just having those problems placed at the end of a lesson or topic, which reduces their need to think deeply. So there's lots of benefits of SSDDs. They induce retrieval. They're retrieving strategies from their brain that they've covered before. We're focusing on the differences as well between these questions, and they can also ensure that new learning doesn't necessarily interfere with prior knowledge. Carrying out the process is secondary to retrieving which process is needed. As an activity in the live session, we set this. Here's the surface. Okay, this happens to be my own kitchen cupboard that I emptied and put a tape measure across. So we've got some cans in there, and what we said is we're going to create an SSDD problem using that as the context. And here we have one of the groups, room 4, So they have come up with more than 4 questions, but they've chosen a nice selection. So the first one, what is the volume of the cupboard? So for that, we would need to know the depth as well, but that's okay. You can always give that in the question. Here we go. There are 2 bean tins and 5 sweet corn tins. If one tin is chosen at random, what's the probability that it is sweet corn? So we're bringing probability in here. A cupboard shelf is 6 centimeters high. Each can of beans is 12 centimeters high. How many cans of beans can be stacked on top of each other? So that's quite a straightforward question. How many cans of each food type can you stack across the back of the cupboard? What is the ratio of beans to sweet corn cans? So you could sort of extend the problem, filling up the whole cupboard and then looking at the ratio if you maximize the number of the different types of sizes of cans. Another question here, we're looking at percentages. Calculate the percentage difference in mass between 1 stack of sweet corn tins and 1 stack of cannellini bean twins, and we would need to know the weight of those as well, but obviously you can give those. And here is another percentage question. Calculate percentage difference in the area of the tin surface. Oh, brilliant. Give the formula, but actually getting them to think about the surface area of the tin. And that's actually when you're introducing surface area of cylinders, it's a nice thing to think about tin cans, because if you take off the wrapper of the tin can, what do you get? You get a rectangle. So if you're looking at the surface area of a cylinder, you are looking at a rectangle and 2 circles. So you would need the circumference of the tin as well as the height in order to be able to look at the surface area. So there's one of the groups, and if you've already accessed the Padlet, you'll be able to see what the other groups came up with as well. Okay, now the questions that we've looked at, most of them tended to have had an end goal, and that's certainly true for any assessment questions that you look at. They all have, a clear end result, an answer that you're trying to find. That can sometimes cause issues with cognitive load and lead to low participation. There's only quite often one right answer, and that can impact on confidence if learners get the wrong answer. It may lead them to throwing out methods that they tried even though they were on the right track. Goal-free problems can lead to increased participation. They can reduce cognitive overload, and because there's no end goal, there are lots of valid answers, which is good for confidence. So we can take some information. So for here, I really like parkrun basically, and in the week before I was creating these resources, just so happened that His Majesty the King visited the parkrun at Sandringham, just a bit of a surprise visit, I think ahead of Cancer Week, to raise awareness for people living with cancer. And so I've taken the Sandringham Parkrun event statistics, which was these statistics were taken from the start of February 2026, and here we have parkrun statistics. So we've got how many locations there are, how many finishers, how many finishes, how many volunteers, average finish time. Lots of information here. We've got a course map and a course description, 2 laps on a combination of tarmac through the scenic route and woodland trails through the forest. And we've got no specific goal in mind. We're just looking at what can you work out from this information. So here is our goal-free problem. Now I've chosen these statistics because I happen to be interested in parkruns. But again, you can choose something that your learners are interested in or that you're interested in to create a goal-free problem, or you can take an assessment question and use the information from that assessment question, but remove the actual question part so that it becomes goal-free, and just say, what can you work out from this information? And so in the live session in breakout rooms, we completed this activity. I gave everybody the opportunity to see what they could work out. And here, this is room two's ideas. Now they haven't actually done the maths here. They've just said what they can work out. So it's up to you if you're setting an activity like this. You get them to do some sums, perhaps. You get them to do some calculations. But things that you could work out from this is what percentage of finishes are PBs. So PB is personal best. So you can see the personal bests achieved from parkrun as a whole is 10,398,438. The ratio of volunteers to finishers, percentages of amounts, any combination of, speed, distance, time. Oh yeah, so you can work out, if you've got the average finish time and you've got the distance, which is 5 kilometers, you could work out the speed that somebody who runs the average is running. Average races per runner, because you've got finishers versus finishes. So if you divided the 47,284 by finishers, then you would get the average races per runner. So lots of averages that you could find. The fraction of a lot of the details from Sandringham compared to parkrun as a whole. The probability of someone is picked is a Sandringham runner, so somebody chosen at random from parkrun. What's the probability, as a finisher, a parkrun finisher, that they are a Sandringham finisher rather than just any of the other events? Sandringham average time is 13% higher than parkrun. So what is the parkrun average time? So there's lots of different calculations that you can do. Perhaps you can come up with your own and think about how you could use goal-free problems with your learners. Oh, number-free problems. Okay, number-free problems are a middle ground between questions that require an answer and questions that have no specific goal. So in this example, an insurance company asked people why they had paved an area of their garden. A fraction of the people said the main reason was to create a patio. A fraction with a different denominator said the main reason was to create a parking space. The rest gave other reasons. How would you work out the percentage that gave other reasons? So this is actually a past assessment question, and all I've done is remove the numbers. The focus now is not on completing calculations. We can't complete calculations because there's no numbers. But instead, we need to identify how you would go about solving this. So we set this in breakout rooms to complete some number-free problems. And if you're watching this recording, you can try it for yourself. You can access the Padlet. It's the same Padlet link that I shared earlier using the QR code on the screen. And if you go to the final card, you will be able to download the resources for the number-free problems and also the final activity that we're going to look at, decoding maths problems. Once learners have covered the subject content and they've developed their problem-solving skills, then it's time to look at assessment questions. And of course, these are going to need decoding. One way to approach problem-solving questions is to use rucksack. Read, understand, choose, solve, answer, and check. Taking the time to read, fully understand the question, and choose strategies is important before launching into solving a question. So let's take a look at this. Jazz wants to know how much it will cost to replace the kitchen worktops. He finds these prices for different custom-made worktops. Jazz needs a total length of 175 inches of worktop. He can buy the exact length of worktop needed. 1 inch is 2.54 centimetres. Use the modal price to work out how much the worktop will cost. You must show all your working. Okay, so we've read our question once, and our number one top tip from the Chief Examiner report relates to reading each question twice. On second reading, it can be helpful to highlight the important information. So here we've highlighted the important information, and you can do this. If it's a paper-based paper, you can encourage your learners to have different coloured pens with them to highlight if it helps them. In an on-screen assessment, there is a highlighting tool. So please do make sure that your learners are aware there's a highlighting tool that they can use should they wish to in an on-screen assessment, and make sure they know how to use it. So first thing we've done, we've read the question, we've read it again and highlighted key information to help us to understand what this question is asking. And if we've read and we've understood, the next part of Rucksack is to choose. We need to choose the strategies we need to use. So let's see, what do we need to do? First of all, let's convert those inches to centimetres, because here we've got price per metre, and we know how many inches of worktop Jazz needs. So first thing we need to do, the strategy is a conversion. So we would, we're told that 1 inch is 2.54, so we would need to do 175 divided by 2.54 to give us the, multiplied by, sorry, I beg your pardon, to give us the total number of centimetres. So we do that conversion. Is that all we need to do? No, because then we need to convert into meters, because we're told the price per meter. So once we've got our centimeters, we'll then convert into meters. So that'll be a straightforward dividing by 100, since we're looking at just the one unit of measurement here, the length. We need to find the mode. Okay, and so for this, we've highlighted here, we can see that mode. There's a value that appears twice, and all the other values only appear once. So there's another strategy. And then all we would do is multiply that mode, that price, by the number of meters. Those are the strategies that we need to use in order to solve that question. And if you notice, this is a 4-mark question, and we have clearly identified 4 strategies that we're going to use, 4 steps. So we can be fairly confident that if we do these 4 steps and we note down those 4 steps and are working at all times, it does say you must show you're working, then all being well, providing we get our calculations correct, we should get all 4 marks. But if our process is correct and we get some wrong answers in amongst there, if our process is clear, then we can absolutely achieve marks for the process that we have followed, even if the calculations that we do end up being incorrect. Now, you'll notice that we haven't done the final parts. We haven't done the SAC. We've only done the read, understand and choose. Well, that's because, truthfully, the SAC part, the solve, answer and check, are the more straightforward parts of solving a problem. The hardest part is deciding what process, what strategies we're going to follow. If you have been successful in your teaching of the underpinning skills, please refer to my other session that's available on the YouTube playlist, looking at underpinning skills. If you've been successful in teaching those skills, then your learner will be able to use those skills to solve the problem and then answer whatever that question is asking, and then they can do their check. But for the purpose of this session, we are purely focusing on those problem solving skills. So what we did in the live session and what you can do for yourself, because you've got access to that Padlet, is you can look at those problem solving questions, the decoding problem solving questions document, and go through. Do this as an activity for yourself. Highlight the key information, choose the strategies that you need for the question, but don't solve the question. All right, just go through as an activity, and you can do this with your learners. Tell them, today we're going to do no calculations at all. You can put your calculators away. and we are purely going to be problem solving. It makes for quite a different type of a lesson, and actually a very productive one if you're purely focusing on decoding those questions. So try it for yourself, see how you get along with it, and then you could perhaps consider setting this type of activity for your learners. We will end with a summary now, but first you can think of what would your key takeaway be from this session. Decide for yourself what's the one thing that listening or watching this recording has made you think that you might do differently. Problem solving skills are assessed at 75% in the assessments at all levels. It's important to build in activities to develop your learners' problem solving skills while you're teaching the underpinning skills. Learners must first master underpinning skills to be able to approach problem solving assessment questions that assess that content. Try to build in time to practice reading, understanding and choosing what strategies an assessment question requires, rather than only focusing on the solution. If you have any questions related to this session, please don't hesitate to get in touch. And one way that you can get in touch is by completing our feedback form. This feedback form is for this recorded session. It's completely anonymous unless you don't want it to be. So at the very end, there is a question that allows you to give your email address. If you have follow-up questions, for example, about this session, then please do, you can request that we contact you and leave your email address. Otherwise, your feedback is completely anonymous, and we really do appreciate your feedback in watching these recordings. We do try to improve the recordings that we do for you. So please, if you do have a few spare moments, we'd really appreciate you scanning this QR code and completing the feedback form. You'll find all our upcoming CPD events from our Functional Skills events page on the website. You can just find it in the delivery support section, Functional Skills. You'll find all of the Functional Skills events. And coming up in March, we've got Functional Fluency, Maths Strategies for SEND Success, and another Functional Fluency session that we'd love to see you along for is Enhancing EAL Support in Maths Functional Skills. So lots of other events as well coming up, as well as drop-in clinics that you can just come along and ask questions at. On my Maths Padlet within the NCFE Maths and English Padlet, I've placed links to various different resources that we have used in this session, as well as other third-party external links that you might find helpful. So please feel free to access our Padlet. Thank you so much for your time in listening and watching this recording. You've got key contacts on this final slide, and if you do have any further questions, please do get in touch. And there's the little QR code there for our survey for this recorded session as well. Thank you very much. Enjoy the rest of your day or evening or whatever time of day it is for you. Thanks.